Continuing on, let's take a look at page 2. We got Drew. He bought 4 candy bars and 2 packs of gum. And if we skip ahead, we're going to let G be a gum, and C is going to be a candy bar. So he bought 4 candy bars, so we're going to write that as 4 times C. And he bought 2 packs of gum plus 2G, and he spent $9.80. Our second equation tells us 2 packs of gum cost the same as, so 2 packs of gum, so 2G costs the same as 3 candy bars, so plus 3C. Now notice on this one, we don't necessarily have to solve for G, because in both problems, we have 2G. So what I'm going to do in my first equation, I'm going to replace 2G with 3C. So now I'm going to write 4C plus, instead of 2G, I'll write 3C. That equals 980. Now I can solve that problem. 7C equals 980. I'll divide both sides by 7. And then, I can't do that in my head, so we'll use our calculator. We'll take 980 divided by 7, and I'll get 140, or 1.4. So, the cost of a candy bar is going to be $1.40. Now I'm going to turn around, and I want to find the cost of gum. And I think I will just use my second equation. So I'm going to say 2G equals 3 times 140. So 2G equals 3 times 140 is 420. Divide by 2. G is 210. And then I want to write a sentence. So I'll say gum costs $2.10 per pack. And a candy bar costs $1.40. Now on question number 7, unlike the other ones, it's not so easy to see, is it? Because I don't have any variables the same. So what I'm going to do is I'm going to pick one equation and get one variable by itself. I think I'll use the first equation and, I didn't mean to do that. I'll use the first equation and I'll get y by itself. So to get y by itself, I will minus 3x from both sides. And then we'll say 2y equals negative 8 minus 3x. I'll divide that by 2. And so then we'll say, let me pull that down a little bit so we can show our work. So y is going to be negative 4 minus 3 halves x. Now to solve that system, I'm going to replace y in the second equation with negative 4 minus 3 halves x. So now we'll say negative 6x minus 4 times negative 4 minus 3 halves x and that will equal to 12. So I'll get negative 6. Let's distribute that negative 4. I'll get positive 16. A negative times a negative is a positive. 2 goes into 4 twice. 2 times 3 is 6. Equals 12. Kind of ran out of room here. I think I can fit one more line here because notice my x's cancel, don't they? So I get 16 equals 12. 16 does not equal 12. That's not true. So our correct choice on this one is going to be no solution because it's not true. If it was true, then it would be infinite solutions. Let's keep on going with question number 8. I want to find the value of c that's going to make my equation true. So I think I'll look at the second equation first. And in my second equation, I'm going to minus 3x from both sides. So then we're going to get y equals 5 minus 3x. I'll substitute y for 5 minus 3x in my first equation. So I will say 9x equals to negative 3 times 5 minus 3x plus c. And I want to solve for c. So this seems kind of weird what we're doing, but we're going to find out here. So 9x, distribute my negative 3. I'll get negative 15 plus 9x plus c. Now I want to get c by itself. So what I'm going to do here is I will minus 9x from both sides. And I will get 0 equals negative 15 plus c. I will add 15 to both sides. I'll get 15 equals c. Now, for which value of c does the system have infinitely many solutions? Well, that's exactly because notice I've canceled my x out. So c being 15 will be infinitely many solutions. If I got a solution, I'd have to have a value of x or something like that.